Welcome to the deep dive. Today we're jumping into artificial intelligence. Essentially, it's about building computers that can tackle things we usually think need human smarts.
Yeah, exactly. Things like learning, reasoning, solving problems, even perception and, decision making. It's all about machines perceiving and acting to achieve goals.
And it's kind of everywhere now.
Oh, absolutely. More than you probably think. Your Google searches, YouTube recommendations, Netflix picks.
Siri, Alexa.
Yep, those virtual assistants, self-driving cars, even things like ChatGPT or AI art generators, it's all AI.
It's funny how often the really useful stuff isn't even labeled AI anymore.
Right, it just becomes technology. But the field itself, it actually goes way back.
Yeah, 1956, wasn't it? Established as an academic discipline.
That's it. And it's had this cyclical history, huge waves of optimism.
Followed by those AI winters.
Exactly, where funding just dried up. But then around 2012, things really picked up again.
Deep learning was a big part of that.
Huge. And then post-2017, the transformer architecture. That really kicked off the current, AI boom we're seeing.
And all the discussion about regulating it now,
Yeah.
especially the advanced generative stuff.
So yeah, our mission for this deep dive is basically to unpack the core goals and the techniques driving AI research today.
Okay, where should we start? Reasoning, problem solving.
Sounds good. Early AI tried to mimic how humans reason step by step. For puzzles, logic games.
Logical deduction.
Right. But they ran into this problem called the combinatorial explosion.
Too many possibilities to check.
Way too many. For complex problems, the number of steps just blows up. Plus, let's be honest, humans don't always use pure logic.
No, definitely not. We use intuition, gut feelings.
Fast judgments, right. So getting AI to reason efficiently and accurately, especially with uncertainty, is still a massive challenge.
Which connects to how AI handles knowledge, I guess.
Precisely. Knowledge representation. How do you give an AI the background info it needs to answer questions or make deductions?
So you need, databases of facts.
Yeah, knowledge bases. And ontologies, which sort of define objects, concepts, and how they relate within a specific area.
But common sense, that seems hard. All the obvious stuff we just know.
Incredibly hard. It's vast, often not easily written down, kind of sub-symbolic. Just acquiring and representing that knowledge is a major hurdle.
Okay, so what about planning, making decisions?
So think of an AI as an agent. It perceives its environment, it acts.
And a rational agent is one trying to achieve goals.
You got it. Automated planning focuses on hitting specific targets. Decision-making is a bit broader. It involves preferences, trying to maximize expected utility, get the best outcome overall.
But the real world isn't predictable.
Not at all. That's where you get into things like Markov decision processes, planning under uncertainty, and even game theory for competitive situations.
And underlying a lot of this is learning, right? Machine learning.
Absolutely fundamental. ML is about programs getting better at tasks automatically through experience. It's been core to AI since the beginning.
And there are different types.
Unsupervised learning finds patterns in data without labels. Supervised learning uses labeled examples, this is X, this is Y, for classification or prediction.
Like identifying spam email.
Good example. And then there's reinforcement learning, where the agent learns by getting rewards or punishments. Trial and error.
Sounds like how we learn too, doesn't it?
Kind of. And you also hear about deep learning, using those artificial neural networks with many layers.
Right, let's touch on that. And NLP too, natural language processing.
Yeah, NLP is huge. Getting computers to understand and, communicate in human language.
Speech recognition, translation.
Question answering, yeah. Early attempts use strict grammar rules, but modern NLP leans heavily on deep learning. Things like word embeddings, transformers.
That's the tech behind models like GPT.
Exactly. Which is why they can generate such coherent text, even pass exams sometimes. It's impressive.
And perception. Computers seeing the world.
Machine perception, yeah. Using sensor input cameras, microphones to understand what's going on. Computer vision is the big one there.
Recognizing objects, faces and photos.
That kind of thing.
Okay, so we've covered the goals. What about the core techniques making it happen?
Well, there's search and optimization exploring possibilities to find the best solution. Think game AI figuring out the best move.
Using logic.
Logic plays a role, yeah. Formal logic for reasoning, but also probabilistic methods for dealing with uncertainty. Bayesian networks are key there.
Right, because the world isn't black and white.
Not usually. Then you have classifiers and statistical learning methods, pattern matching, basically. Decision trees support vector machines, neural networks.
Neural networks again. Deep learning's foundation.
Exactly.
Yeah.
Artificial neural networks, inspired loosely by the brain. Deep learning uses networks with many layers to learn really complex patterns from tons of data. That, plus powerful GPUs, has driven huge progress recently.
So wrapping up, AI isn't just one thing.
Definitely not. It's this incredibly broad field, a collection of diverse goals and, frankly, very sophisticated techniques, from mimicking basic reasoning to complex pattern recognition, even creative stuff now.
And it's changing so much, impacting our lives constantly, often without us even realizing it.
It's deeply integrated.
So here's something maybe to chew on. As AI gets more capable, more integrated into everything we do, what aspects of intelligence, of understanding, maybe even consciousness, what still feels uniquely human, and how is our relationship with these machines going to evolve?
That's the big question, isn't it?
That's your deep dive for today. Thanks for tuning in.